I'll tell you what, I got a general structure in my head how I want this video to go, and I keep screwing it up. I forgot my Royal Enfield mug at work. I left it in my service truck. And I didn't think I was going to be working on anything this weekend, so I left my good flute meters and all that stuff in there. So if you guys can deal with some rank amateur motorcycle mechanicking and some substandard, subpar tools, well, buddy, I got you covered. Let's go check this out. All right, so today we're going to look inside the bike. We're going to reference the owner's manual for the bike, and we're going to take a quick look. Oh, quit kicking the damn stand, John. We're going to take a quick look at something that I didn't even know was a thing until just recently. So let me throw a little disclaimer out here first. I am not a motorcycle mechanic, but I do have a basic knowledge of motorcycle mechanics. I have never, until this motorcycle, bought a new motorcycle. I've always bought them used, and except for once, they didn't run when I bought them. So I started in 1994 or 5, I think. I think it was 1995. I bought my first, maybe it was 96. Anyway, I bought my first motorcycle. It didn't run. It was a 2-stroke carbureted 1972 Kawasaki KT100 in Sunrise Surprise Orange. Really liked that bike. It was a fun little bike, little trail bike. Little trail bikes are fun. Anyway, the important thing to take away from this is I am not a certified motorcycle mechanic. I am not a Royal Enfield technician. I'm just some guy on the internet, and you need to double check everything I say here because I'm not 100% sure of it myself. But that being said, I'm fairly certain. So let's hit this hard. All right, so I made a video the other day. It was called Charge It, and you go back and watch that if you want. It's a really long video. It's me installing a charge port on this bike and a USB port to charge my devices on this bike. And I connected all of that stuff directly to the battery and ran it forward under the tank, zip tied it to the frame, all that stuff. In the comments section, and buddy, I'm going to butcher your name here. I got a comment from Aditya. Like I said, I'm going to screw that up. Anyway, I really appreciate that comment. That's one of the things I really like about YouTube. Is the comment sections, and they're talking about getting rid of it, and I hope they don't. I hope they don't, because YouTube is an incredibly powerful tool for the home do-it-yourselfer, motorcycle mechanic, plumber, all that stuff. It's also a tremendous waste of time, but I enjoy wasting my time making these videos and watching your guys' videos. It's better than television. So, what my buddy from Mumbai, my biker buddy from Mumbai put on there was interesting video or something. I'm putting it up here. You're looking at it. Why didn't you use the accessory port in the headlight housing? Well, that's a darn good question. I didn't know it existed. This is that port. This is an empty port. I'll roll on a picture of it here. They've put what appears to be dielectric grease to cover, I don't want to disturb that. I think I did anyway, but I went in the back because they didn't seal that. So my positive probe is missing. The negative one's stuck in there. You can see that. So why didn't you use that? So I don't know. I didn't know it existed. I didn't even know it existed. Not a bad idea. So the point of this is it's switched to the ignition on a relay. You see the meter come across. I'm going to go ahead and turn this back off. We have power only when the bike is turned on, and that's great, especially for USB ports. A lot of the little USB ports have a little step down from the 12 or 13 volts to like 2.5 volts, I think is what they mostly run. Again, this isn't, you know, the end-all be-all of information. This is a primer to get you started. You need to go check this stuff if you have questions or doubts. But this is pretty good information, I think. Anyway, I didn't know it existed. I really appreciate him commenting on that. That's why I like YouTube. I went on different places and started looking for what is this? What is it about? What is it good for? You know, what's it rated for? All that stuff. Is anybody else using it? And I'm seeing a lot of people are plugging stuff into it, but they don't really have a lot of information about it. And nobody's really able to answer questions. And I'm seeing a lot of people are having problems with it. So I'm going to kind of give you the rundown on what this is, what it can handle, and why you probably want to use it. As far as I can tell, you need to, again, reference your owner's manual. Boom! Reference your owner's manual and make sure that what I'm saying is right. This is a 10 amp circuit. Here's a picture of the fuse. It is position 7. The way I found that out is on page 116 of the manual. You have these cool little fold outs, and they are the wiring diagrams for your bike. And wiring diagrams are easy. You have a power source, which is this is so easy, guys. You have a power source, your battery, and your alternator. Okay, you have lines that go out to switches and then to loads. So the light bulb is a load, a relay is just a switch. When you turn the switch on the thing, it energizes a magnetic coil on the relay, and that coil pulls a switch closed. The purpose of that is the controls that you have up here don't have to handle the whole load. It just goes straight from the power source to here, the full load on that relay switch. That relay switch can be beefy and handle a lot of amp draw, a lot of power use. That's it. And then there's the ECU, the computer that tells the relays what to do and when to do it, all that stuff. It's really simple. So if you just follow the lines, you'll have a positive that comes from the power source. It goes through the switch. It goes to the load. And then the other side of the load, you've got 2 connectors on everything. Sorry, guys. This is really basic stuff, but some guys don't know this stuff. You'll have 2 things on any load. One is the positive coming in. The other one goes back to ground somehow. It goes to ground on the frame right here, or it goes back to the main ground lug, the black one on the battery. You'll notice in the picture on this that one of them is red, one of them is black, sorry. Anyway, yeah, you'll notice that on this one the wire is red and black. That's common. On your switched stuff you'll have different colors, and the wiring diagrams will have that. But anyway, about this specifically, I'm not going to go too much further into detail on that. About this specifically, you got power coming in, you got going back to the ground, and it goes through a relay, and it shows on the wiring diagram here, this relay. You can see that. And the thing is, when you turn the power switch on, it energizes the little magnetic coil on, I believe it's 5 and 6 is the position on that relay. And that magnetic coil sucks in the contactors for position 8 and 9 on that relay. That relay is fused in the box according to the thing in position 7. And in my manual, and here's a picture of that, there is no designation for the fuse in position 7. On the Facebook comments, a guy from Germany jumped in and said, yeah, it's a 5 amp fuse, because I said I'm not sure what it is, because I was posting information as I was taking the bike apart and looking. So Yeah, he says 5 amp. Oh, cool. That's neat. Or what did I say? Sweet or nice. I said nice, you know. And then I came back. Well, on mine it's 10 amp. And on mine it is a 10 amp. Here's position 7 in the fuse box. It's directly under the seat. That's a 10 amp fuse on this bike, this American bike. So I don't know if that's the same in Europe. You'll have to check your manual, guys, and that's the really important part. Everything I'm saying here, you need to double check it. So what is this switch? What can it do? It can do a 10 amp load. If you're going to hook lights up to it, I don't have a problem with that. I would do, actually, that's what I would reserve this port for. If I were going to add additional lights to the bike, I would hook them up there probably. Especially if they're forward facing, like fog lights or running lights, or, you know, LEDs just to brighten the road up a bit. I would use it for that. It is a switch position, so the lights will come on and off with the headlight, right? See that bright? So there you go. This picture shows the Q relay, and I got lucky, guys. It was the first one I pulled out. It killed the circuit. So I'm gonna go ahead and do that one more time. So there it's on, and I am pulling this cube relay, and you see that it killed that. Okay, now these are just switches, guys. You can have power to the system and pull this. You're not going to hurt anything. It doesn't work that way. So you see that went dead. I'm going to plug it back in, and there you go. There's your power's back on. Let's come over here real quick. No edit, no break. And show you which one. On all these 4, it's this one. There you go. Just pull that, and that's... Now when you check this, so here we are. So this is the connector. I went in through the back. As you can see, that's not really protected. They're just there. You want to be careful that you don't pull those out, because they're really hard to get back in, and they're flimsy. They break. As I found out with the tail light, there are 2 of this color, this style, and I broke one of them, so I had to eliminate all those and use butt connectors. I just don't have these parts. But you see, put that little grease in there. That's just to protect it. It's non-conductive usually. And what it does, it keeps the atmosphere off of the components so that they don't corrode. What I was telling you, every load in this system has 2 prongs. You've got the hot coming in, and then you have to have the ground going back, and it goes back to the battery, and the electrons push around, and they're basically like a chain drive, guys. You induce a magnetic field or an oversupply of electrons, and you push the electrons, and they go through the thing. If it's a light, the light's created by resistance on the element, right? Light and heat. It's all light energy. Or it's all, it's all resistant energy or built up energy, and then the light throws off. But those electrons have to come back to the battery or the alternator. It's all electronic. It's all recycled electrons. It is all recycled electrons, guys. Okay, so real quick on this. Come on, focus, dude. Why is that backwards in my rangefinder? Oh, because it's upside down, retard. So the basic way a relay works, and a lot of you guys probably already know this, these 2 are going to be your power coming out. This is power coming in. This is always hot. So we got to run around right now. You've got power coming in here, and then it goes here until you energize this magnetic coil. It pulls the plunger, which pulls the switch down to here, and then you have power going here. So I'm thinking on this one, on the manual, and you see what this is rated for? 20 amps at 12 volts DC. You can run AC power through this at a higher amp draw, believe it or not. This will work for that, but the coil will only work on 12 volt DC. You can switch an AC load with this, but I don't recommend it. I prefer getting the correct part for the correct thing. But anyway, and that's a whole bunch of electrical engineering stuff that I don't really want to get into here. Yeah, when you put power to here through the key switch, right? It puts power to this. It energizes this coil. This goes back to ground, right? And then that pulls that down and it goes to here. So 30 oh, well, it's not labeled down there. 30 has power coming in, and it goes to 87A. And when you energize it, goes to 87B. So I'm willing to bet that these two are your coil. This one's your power in. Let's check that. Okay. On your voltmeter, there should be the little Greek symbol omega. That is for ohms. This one is not auto ranging, so good Lord. Sorry, guys. Gotta tighten that up. So this one's not auto ranging. You got to select the right range on it if you have a meter like that. Included in here, and I know $100 is a lot of money, guys, for a home jobber thing, but included in the doobly-doo down in the bottom, the description, thank you for reminding me, down in the description is an Amazon link. I really like Amazon. I don't support Jeff Bezos BS on a lot of things, but anyway, we're not going to rant about that. There's an Amazon link to a fluke meter that is auto ranging, and it has the loop for testing amp draw. That only works on AC, like your house voltage. It's auto ranging, so if you put it on AC volts, you can go all the way from 7 AC volts all the way up to 460. I think it'll actually handle 600 volts, guys. It's a great meter. It's what I use day in, day out at work. I have 2 meters I use at work. They're both fluke meters. That's the one that I go to all of the time. It's very hardy, very robust. I've dropped it. I've dropped things on it, and it just works. So, okay, I'm going to do this, and we're going to, first we're going to make sure that our meter works. Yes, it does. See that? It's good to have good leads, too. You get erroneous readings with junk like this. Don't do this. It's very bad. So I'm going to touch this one and this one. There we go. Now, it's one of two ways, and it could be that these two are the coil, and that actually makes more sense. These two should be the coil. No? Well, there you go. They're not. I'm actually going to go with the diagram on the thing. I'm going to go with the diagram on the thing lining up with the pegs is probably what's going on. So, like I said, it just makes sense because engineers are engineers, regardless of what language they speak. This is probably your coil. And then from here, you should have continuity from here to this middle one. Yes. And there's no real way to test this, but this is answering the question on Facebook that we got. I have to make sure I touch only that one. His problem is the light is constantly on. So there's that. Okay. And this one, I'm thinking, this one is the switched one. This one is the switched one to this middle. You should not get continuity there until you put 12 volts to here and here. Right? So that's what makes the most sense. That's the way that ought to work. I'm going to post this on I want to put this video on YouTube. Anyway, that's the way that appears to work, guys. That's how that's gonna read across. When I say continuity, that's a measurement of ohms. Is it continuous? Does the switch close? That's the way that looks to me. I could be wrong, and without energizing these outside two, I won't know. So I was saying that I can't really test that cube relay because I'd have to hook power up to it. I don't have alligator clamps and all that. And it occurred to me I don't have to test it to see if ringing it out was accurate. You see, I have continuity. There's a measure of resistance through the thing. So I have my negative lead. I have my negative lead hooked into the frame. The negative on your battery is hooked into the frame also. I guess that bears saying. So if I touch this to the frame on the ohms, I get a measure, which means I have continuity, which means I've got a good ground on my negative lead. So here's what I'm going to do. I'm going to pop the relay out. I don't know why I didn't think of this earlier, but I was sitting there editing the video, and I'm 98% done, 99% done with editing the video. And it occurred to me when I was saying, well, I can't test this. Yeah, you can. I should... Oh, let's kill the light, huh? Yeah, we're good. I should constantly... I'm going to move this back over to 15 volts. I just zip tied this to the frame, guys, so you can see it. Usually I'd lay it down next to it. So I was saying that this one should be power in. So I should always have power in there. So if I touch this, if I'm right about that, if I can even get a connection, one of these should always have power no matter what. Oh, it's the middle one. Okay, that's cool. Oh, okay. Well, you can run it backwards. I said this would be your power in all the time. If I were designing this, that's how I would do it. This would be power in all the time. This one is power in all the time. So that's just the way they wired it. You can see that kick when I stick that into that one. That's this connector, this middle one, right? So this or this on the outside, if that is my coil, if those two are my coil, should get power to energize that magnet when I turn the key on. Oh, let's do it. Oh, there you go. A little bit of a bump. There it is. So this one, and then this one will be my ground going back. And we can test that. Let's turn this off. We can test that by finding that I have continuity from that position back to my spot on the frame, ohms. So there we go. That's verification. It is not hooked up powerways the way I thought. This would be your constant hot, and then these would be your switch positions. It's not. This is your constant hot, and then it cycles back and forth depending on if that magnetic coil is energized between here and here, where it sends power from here. This is definitely your coil. There's just no other way around it, guys. So there you go. There is a way we can test that. I thought I'd share that with you. I was sitting there thinking about that, and what? Well, don't do that. Oh, that's not power. Anyway, I was sitting there thinking, man, there's got to be a way to test that. And I watched that again. And... all right, I'm going to post this in the group on Facebook, and if you guys, any of you have direct experience with that, I'm not going to go hook this up that way and make sure. I'm just pretty sure that's the way that's going to be working. If you have direct experience, comment below, please, or comment in the Facebook thing. But that is the relay that puts power to the accessory switch. This is the California model for the US, 10 amps, like I said. And that's how that relay works. That's why that does what it does. And if you go to hook anything up to this, again, consult your manual. If you go to hook anything up to this, you need to check the packaging and check the amp rating and see what it's rated for. Because if it's too great, like I told him, it might not be this. It might be something else, but we don't know. But these can actually connect, carry that load, get super hot, and you'll see warping on the outside of this if this happens, guys. That thing can actually spot weld itself together and carry that load continuously. So there you go. Like they say, I'm what you call an expert. Don't try this at home. I'm just kidding. Videos for entertainment purposes only. I hope this is a good primer and gets you looking in your book. And hopefully it helps you to understand what's in the book. Use the information in the book. That is the most correctest, rightest way. Again, this is a California model for the United States. Somebody commented before that was a 5 amp fuse. On mine it's a 10. And maybe in the European market it's a 5, and it might be that way in India too, guys. Consult your manual, consult your manual, consult your manual. I hope everything I'm saying here is accurate. I hope it's understandable. Hopefully it's helpful. If you have more knowledge on this, I would appreciate watching your video and your take on it. I'd really like to see what you have to say on it. If you're an actual Royal Enfield technician, that would be awesome to get your take on this. Of a lay person's understanding how this stuff works. So I'm sharing with you what I know, and hopefully somebody out there can do a better job and share it with all of us, help us out with this. But boop, 10 amps, no more, California model. Consult your book, whatever your book says. If it's 5, keep it under 5. Read the packaging on the accessories that you're going to install. That's really important. And I don't care if it's a USB charging port. Read the packaging. Read the labels on the product itself. Make sure that you're underneath that amp rating that your bike actually has. Don't go, oh, John said 10 amps, it should be fine. It didn't work that way. Your bike might be different. So the very first year they ran with them for the first 5 months, and I, well, you know what, we can do 10 amps, let's do 10 amps. And they were 5. I don't know. We just don't know. You have to look at yours. Hopefully that explains to you in an easy to understand format how the electrical stuff, how the angry pixies get from the electricity thing all the way into the doobly-doos that make the thing happen, all that junk. Hopefully that's helpful. All right, guys, I'm going to go get some more coffee, probably have some breakfast by now. And then I'm going to put my bike back together. I didn't actually need to pull it apart for me. Just trying to help you guys out. So have a good one. Happy Thanksgiving. You guys take care. Have a good one. Catch you on the next one.